Hello, my name is Beth Dixon, and this is some examples on systems of equations solved by elimination. This presentation is designed to be used as a supplement to your learning and does not replace classroom instruction. Your number one tool in learning is your classroom instruction. Okay, let's look at some examples here of some systems of equations. In example 1 podcast on elimination, we looked at some equations that only involved direct addition of the two equations, and that immediately eliminated the two equations. In these examples, we will have to do a little bit of work to prep our equations before we can add. So let's look at these equations. Let's start with 3x plus 4y equals 17, and 2x minus 2y equals 2. In these two equations, we should notice that nothing immediately eliminates. 3 plus 2 gives me 5, and 4 minus 2 gives me 2. So neither the x nor the y eliminates. Remember, we want to add these two equations and eliminate something in such a way that we end up with 0. And please ignore the changing color of pens, but I want to emphasize some things here. So we want to eliminate, and when I add, I really like things that have opposite signs. So I'm going to try to eliminate the y's because they already have opposite signs. And so when I eliminate these, I want the 4y and the 2y to have the same number. And when I do that, I want to think, well, how can I make the 4y and the 2y the same number? Well, I could make 4 into a 2 by dividing, but dividing is always more difficult. The easiest thing to do is to take this bottom equation and multiply it by a 2. And what I do to one part of the equation, I'll have to do to every part of the equation to keep that equation true. It's one of the rules of an equation. If I do to one side, as long as I do it to the other side, it doesn't break one of the laws of algebra. It maintains that equality. And if I do it to, I can't just do it to one part of this equation, I have to do it to both parts over here. So I'm going to multiply the 2 times the 2x and the 2 times the 2y, and technically I'm multiplying that 2 over on this side as well. Generally I just write it down on this side and just multiply and think of it as distributing it all the way across. Notice that's not multiplying it by 2 twice. I'm just saying that this is the normal way I write it, that normally I don't bother writing it on this side so that I'm having less issues and less things to write. So I end up, again, excuse the changing color here. So I'm going to bring over the first equation as is. 3x plus 4y equals 17. And then 2 times 2x gives me 4x. 2 times a negative 2 gives me minus 4y, and 2 times 2 gives me 4. 3x plus 4x gives me 7x. 4 and minus 4 excuse me, cancels out. 17 plus 4 gives me 21. Divide by 7 and divide by 7. X equals 3. Now, we want to plug that back in to the X. So we're going to plug it back in for the X. So that's going to be 3 times, and we're going to plug the 3 back in for the X into that top equation, plus 4y equals 17. Then 3 times 3 is 9, plus 4y equals 17. We'll subtract 9 from both sides, and that will give us 4y. 17 from 9 gives us 8. Divide by 4, divide by 4, and y equals 2. So x equals 3 and y equals 2. And if we need to write it as an ordered pair, that would be 3, comma 2. Okay, let's continue on to another problem. Okay, and in this problem, our equations are 3x plus 2y equals 4, and 2x plus 5y equals 21. And again, notice that these are set up to do elimination with the x's over the x's, the y's over the y's, and the numbers over the numbers. And as we do these, we want to see that as we look at these, even though they're set up for elimination, 3 plus 2 or 5 plus 2 does not eliminate. We don't have anything to eliminate, so we're going to have to do some work. The next thing I want to look for is, are there opposite signs? And in this case, they're not opposite signs anywhere. We don't have anywhere where we can make it an ease of signs. So it will not matter whether we eliminate the x's or the y's. So I'm going to choose to eliminate the x's here. And as I do that, I want to think of a number that 3 and 2 can both go into. And if I look at 3 and 2, what can I multiply? I can't add x's to both sides to change these numbers, because then I'd have an extra x over here that doesn't help. I can only multiply. So what number do these two both multiply that I can make them into? Well, that would be 6. And I can take this and I can multiply this top equation through by a 2, and I can multiply this bottom equation through by a 3. Well, the problem with doing that is then they'll both be a positive 6. I need one of these equations to be a negative. And it doesn't matter which of these equations that I do that with, so I can choose either one or the other. So I'm going to make this top one a negative 2. And again, it doesn't matter which, it just needs to be one of them to be a negative. And then I'm just going to multiply everything through by that negative 2. So 3 times negative 2 gives me negative 6x. 2 times negative 2 gives me minus 4y. y, and negative 2 times 4 gives me negative 8. Then in the second equation, 3 times 2 gives me 6x. 3 times 5 gives me plus 15y equals 3 times 21, which gives me 63. Now, as we look at this, we're going to see that we now have those 6's, and they're going to eliminate. We can cross out the negative 6 and the positive 6, and that will give me nothing. Add the negative 4 and the positive 15, and that will give me 11y. And negative 8 and a positive 63 will give me a positive 55. Divide both sides by 11, and y equals a positive 5. Then, of course, we want to plug this back in, and we don't want to plug it back into where we've multiplied and messed with it. We want to plug it back into one of the original equations, and I always just choose the top one for ease. And so I'm going to plug it back in for the y, so that's going to be 3x plus 2, and then in place of the y goes the 5. So that's 2 times 5 equals 4. So that's 3x. 2 times 5 is 10 equals 4 minus 10 minus 10. 3x equals negative 6. Divide by 3. Divide by 3. And x equals negative 2. Now we have our x equals negative 2, our y equals 5, or if we want to write it as an ordered pair, negative 2, comma 5. And so here are two examples of how to solve with elimination when we need to use multiplication to prepare the equations for elimination. If you need additional help, be sure to stop by room 222 of the Math and Behavioral Social Science building, and we will be glad to give you more help in the math lab. Thank you for watching.